Hello, everyone. Thank you for tuning in to this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza, and really excited to bring you each week a new topic on something related to cloud native. And that's what we are most excited about. And that's what we think you are as well. That's why you're tuning in. And so, this week I'm really excited because I'm going to be talking with someone who is no stranger to the show here. He's been here before a couple of times. And he's back here because there's been some new development at his startup. And we want to talk about that. So we have with us Alex Olivier, who is the co-founder and chief product officer at Cerbos. That's Cerbos. Cerbos. In case you haven't heard of them, they're an authorization tool. They went GA just mid last year sometime, and yeah, they're moving fast, making a lot of changes. Every few months, they've got a huge release coming out. So that's kind of the stage they're in. So it's always exciting to talk to Alex because he's always got something new to share with us. Alex, great to have you with us. How you been?
Hey, Twain. Yeah, I've been great, thank you, and thanks for having me again. It's been a whirlwind of a year or so since we last spoke,
Yeah.
and very much kind of looking forward to this conversation, and so we can speak about kind of what's going on in the world, because it all seems a bit crazy right now, without trying to mention AI too soon.
Yeah, absolutely. The first two times actually, we were talking all about authorization, and of course,
Mm.
that is like your core domain. But since then, especially this year in the past few months, something has been brewing in the space. There's something new on the corner. Can you tell us what's happening? What's this, what's something that's really influenced your product development and the way you see your product and what it does in recent times?
Yeah, absolutely. So the biggest sort of trends right now, and I just last week I was in Identiverse in Vegas, which is the big sort of IAM conference every year, um, and really what is being spoken about and what the actual technology implications are slightly different. So everyone obviously has to talk about AI, and we have to talk about AI agents and how these systems are evolving and working together and getting smarter and doing more on behalf of the user, etc. But the underlying problem that comes with these and the problem that impacts what you do as you build out your identity fabric is how you handle identity in these cases. We're all used to sort of hopefully you're used to giving unique workload identities to your services, your containers. Kubernetes has service accounts built in from day one, but we now have this plethora of non-human identities or NHIs as it's now being called in the industry. And this isn't a new problem. They've been around for ages. The moment you give a API key to a service to use, you give an identity or a set of client credentials to say a CI job, that is a type of non-human identity. But we're now really at the point where we're having this explosion now of non-human identities across the architecture, be it those more traditional use cases of giving a API key to a service or giving a service account to a CI job, etc. But where it's really becoming a problem is we're now dealing with workloads that are going to be spin up, very ephemeral, and acting on behalf of users. And you now have this challenge of how do you give that thing an identity? How do you give that thing a attenuated identity based on the human that made it? So you now need to like start issuing unique identities that are limited, that have much more controls around them because they're only acting inside of these agent flows that are going on. And this whole thing is exploding. I think one of the recent reports out from Gartner is there's for every one human identity you have in your system, you have somewhere between 45 and 80, depending on which report you read, non-human identities. So if you're a system with a million users or an enterprise with a million users, you're going to have knocking on 100 million potential non-human identities on average across the stack. So this is a real explosion going on, and how you manage that, how you manage the evolution of the life cycle of those is really key. And then where Cerbos comes in is how you then authorize and enforce the permissions of those non-human identities, which is where we really been focusing as a business for the last few months.
All right, really interesting. Non-human identities. If we were to put it in simpler terms, would it be accurate to say it's kind of like passwords for um, software tools or passwords for machines or is there another simpler way to explain it?
Yeah, exactly. So the if you think of how you establish your identity as a human, the most common way right now is you put in a password. You're trying to give it a credential, you're using your password. maybe using pass keys or something like that. But essentially, you're establishing your identity by providing that credential. The same problem it happens with software and services and IoT devices and such, where you need to basically establish an identity for those services or those workloads, so those workloads can do something inside of your infrastructure. This microservice needs to be able to talk to S3, let's say. So you need to give it a AWS identity, and then you need to provision that on a bucket. So it's the same problem, just now applied to things that aren't humans. And it's not necessarily just software, but if you start thinking of, if you have a dog or a cat, that animal probably is going to be microchipped, so that has an identity. You have a car which connects to the Wi-Fi and sends up data. That car now is an identity. So it's essentially everything that needs to communicate needs an identity, and we need to go through the same process of issuing usernames and passwords to humans. We need to do that for these other non-human identities as well.
Interesting. The question that comes to my mind is, why can't someone like an Okta solve this problem using the same principles that they've been using to solve the problem of human identities all these
Mhm.
years?
Well, that is very much where this problem is being solved inside of the IDPs and IAM solutions out there. Um, on the enterprise end, you got like the CyberArks of the world. From the lower, on the more SaaS side of things, you have the Oktas, Authors of the world, and workload identities, and it's solving the same problem, which is how do you essentially do the joiners, movers, leavers process for something other than a human, other than an employee, other than an organic thing sitting behind a keyboard. Um, so all the tooling we're all used to and built on top of the IDPs of the world are very much extending their platforms to support these other sort of non-human type identities and the different workflows, the different processes, and the different governance levels that need to come with them. Um, there's either the legacy companies are building this into their feature sets, or there's a plethora of startups out there now that are building out identity, workload identity, and non-human identity management. But the common theme across all of them is great. Now you got an identity, you now need to actually enforce and authorize based around it as well.
Mhm. I'd like to get into a little more of what you were just explaining to talk a bit more about the life cycle of a non-human
Mm.
identity. Uh, Talk to us about some of the background, like how is it created, how is it provided, like how is access shared, uh,
Yeah.
how is it revoked, rotated. There's so many stages in the life cycle. Describe it for us.
Well, the challenge is very much that this life cycle isn't being managed. So if you look at what happens today, let's say you want to go and set up a CI job and GitHub Actions that maybe writes some asset to S3. You're going to go into your AWS account. You're going to go and create a new AWS service account. You're going to take those credentials, the access key and access token secret value, and put it as a say a GitHub Actions secret. And now that is permanent. That is persistent. That credential is going to potentially outlive that pipeline. So if someone goes and deletes that pipeline from your CI pipeline, that credential is still going to be living in AWS unless you have governance around it. So what traditionally is happening is we're creating these long-standing, long-lived credentials and long-standing privileged identities, which are going to outlive the service, going to outlive the human that generated that, is going to outlive potentially the business, depending on how things go. Um, so the creation is very commonplace and can be done in numerous ways. It's the how you then manage the ongoing life cycle of that. How do you manage the uh, further provisioning or deprovisioning of the services user credentials, or how do you completely remove that credential at the end of its useful life cycle? And that is where we end up breaking a lot of those zero trust principles of least privilege, zero standing access type models, which if you're building a proper architecture, you need to have baked in there. So this whole process isn't managed, which is really why there's such a lot of hype going on with this right now, because the number of non-human identities is going to be growing exponentially as we start giving more credentials to agents, as we start giving more credentials to services. And this needs to be fixed now, and then the system and your architecture you're building needs to be able to actually use those and leverage those and understand that life cycle when it comes to actually using these things in the real world.
Interesting. And so when it comes to, let's say, we want to fix this problem, we want to manage them better, the NHIs. What are some of the anti-patterns that you would say, that someone should watch out for? I'm thinking something like, probably don't try to do things manually, and deleting
Yeah.
manually. You need to do this, with some sort of tool that can work at scale. Uh, are there other patterns like that? Is this a pattern? Talk to us about
Yeah.
some of those patterns.
So we're looking at purely from like a developer or a DevOps point of view, using
Mm,
things like infrastructure as code, Terraform, OpenTofu, what's the new one that everyone keeps going on about? Pulumi. These are technologies that really have been great for serving us for actually building infrastructure, but equally they can create and manage the lifecycle of service accounts, which is kind of one of the first real use case that probably everyone's familiar with NHIs. Um,
mhm,
so from DevOps, um, the anti-pattern is if you have to go into AWS or Google or whatever and press create new service account and download that JSON file or download those creds and copy and paste, don't do that. That is um, a going to open you up to say to a whole world of pain. So don't do that, please. The next, if you're more on like the enterprise side of things, if you're more on building and running architectures inside of companies, be it in-house systems or sort of commercial off-the-shelf products you've built in and rolled out inside of your business, then having to go in and like manage the credentials and manage the identities inside of each of those systems is a sign that something's not quite right. You really want to be looking at how you can put the same level of automation around that and going and look at the privilege access management tools or the IGA tools and making sure you have governance over what's happening inside of all those architectures and all inside of those systems is a key one. And making sure you have that oversight and make sure that auditability, making sure you have that sort of control plane and a single pane of glass to see exactly what's going on inside of those systems. And the final thing is, uh, I would say the anti-pattern is if you're issuing identities and then blindly trusting the identity, that is wrong. So if you go, right, I've been given a credential, I can just assume that this credentials should always be allowed, and kind of moving away from a model of protecting a service with just an identity, but actually going down to a lower level authorizing access based on that identity at runtime. When we talk about authorization, we used to always talk about admin time, authentication time, and runtime authorization. So admin time in this context would be when you go and create that NHI in some system and you give it a role or a permission to do something. That is long-standing access, that is continuous access, that is sort of privileged access at that point. So, which isn't good because you now are giving long-standing access to something. But at authentication time, so when that NHI is leveraged and authenticated against the system, you might say do an OAuth to client credential kind of type exchange. So when that authentication event occurs against the authorization server, you need to make a decision what scopes and claims go into the token that gets returned back, and you need to be really thinking about which claims or which scopes should be put into this token based on the specific job that this service or this NHI needs to be doing at that moment in time. And just giving permanent sort of read access or write access to some bucket for the lifespan of that token is not real time, it's not contextual, and it's not continuously being authorized. So
mm,
that doesn't work. And then when we talk about runtime authorization, it's about the checks you do on whether a particular service or a particular entity can do a particular action on a particular resource. That is where you get to the level of granularity that truly lets you model a zero trust architecture. And I always say when I've been speaking at events and panels and things is that we've now moved into a world where zero trust isn't just a white paper. Zero trust is actually something you can truly roll out because of the technologies and the tech stack and the identity fabric, which is coming out and truly is actually a set of products or services and open source projects that you can roll out and meet this model.
mhm, mhm. Wow, there's a lot of detail that you shared. That was really interesting. I want to talk a bit about just your journey in the past few months as you've thought
Mm.
about all this and connected this to just your product itself. Was there any particular aha moment that you had during that phase where you realized, okay, this connects with this, and I
Yeah.
did this before. Could you tell us a bit about that?
Yeah, absolutely. So really our kind of first steps into handling authorization for NHIs with Cerbos really came from us speaking to our current customers, and they're like, yeah, we're already doing this thing. We kind of give identities to services, and then we pass that identity to Cerbos to authorize the check. And we're like, well, that's interesting, because there's someone basically using our product in a way that, for a use case that we haven't really been pushing or really haven't been advertising. The beauty of how service has been modeled is it's agnostic to where an identity comes from. So they've been able to take our runtime, 3+ years ago and put it into their stack and do this kind of authorization, which only now, 3 years later, the industry as a whole is much more talking about. So kind of the canonical use case we're seeing across a number of our customers that have done the work themselves to build this out is when a request comes in, that is from an end user. So, Twain, you're logged in, we have some token, we have some key that identifies this as you. That request then goes down to through your service mesh, through the gateway, down to a particular service. That service has an identity given to it. So if you're doing Kubernetes, you might just use the service account. If you're more cutting edge, you might be looking at spiffy identities, which is something we've added native support for a few months ago. But essentially, you now know, right, here's this request from the user Twain, and it's being handled by this particular service with this particular identity. So it might be like the account service. Now, when you want to do your authorization check, can this user Twain do this particular action, this resource? You now have 2 bits of context. We now know who you are, and we now know which service is going to handle it and is handling it. And so we can actually do more fine-grained authorization checks, which is, okay, Twain as a user is trying to edit a resource, but he's trying to edit a resource via the production instance of this particular service. Should that user be able to do this particular action via this particular service with this particular context? And so
Mhm.
from a workload perspective, you might be doing things like, okay, is this request coming from the right cluster? Is this request coming from the right namespace? If you look at Kubernetes world, we have customers that are very much hybrid clouds. They have some things in, say, Google, they have some things on-prem, and there's some services that have to be handled on instances in the cloud. Others have to be handled on instances on-prem in finance, let's say, risk management, risk engine, those sort of things. And so you can now do in those much more fine-grained checks where should your credential leak, let's say, join because there's some malicious actor on the network that snooped your token from the network or something like that, and they start throwing requests at other services, well, that is going to fail the authorization check because there's now going to be a request coming through as you trying to do some action from a service that isn't allowed or not expected, and so that will be blocked. So we really are moving away from this trust the perimeter, trust the network, trust the identity, down to a trust the individual service, the individual call, the individual workload at that moment in time, even individual transactions. If you look at what's going on with the transactions tokens in the world, so you really get to this much, much finer level of granularity. And we've kind of brought that use case to the front with Cerbos. We didn't have to change the product in any way. It's literally just another use case, which testament to our products and engineering team. I can't take any credit for that. That we've built this engine that is so flexible and that we can start spinning up these new use cases very quickly, without really us having to change a single line of code, and keeps enabling our customers and our users to move to a model where they want to be around zero trust, around non-trusted parameters, around runtime authorization.
Mhm, mhm. Yeah, but kudos to you for really spotting just this new use case and really honing in on it and talking about it and really getting behind it. And I think you're kind of zeroing in on it. I think it's probably influencing your upcoming release, if I'm
Mm.
not mistaken. Would you say so?
Yeah, I mean, absolutely. So what we've been working towards, and because the core service is open source, you can go and see it on GitHub, is we'll be bringing more of those capabilities and standards that are being used around workload identities, particularly. So Spiffy, for anyone that's not seen it, is the secure production identity framework for everyone, is what it stands for, Spiffy, which is a standard that's now kind of being developed out there in the world, through IETF, to standardize how you mint identities for workloads. It uses either X509 certificates or JWTs ultimately, and you issue a secure, trustable, verifiable identity to those systems. So what we've been doing with this release and our current release at Cerbos is bringing much more of that into the forefront. And so you can properly verify, say, the trust domain, which is a spiffy concept, of an identity that comes in. And we have a lot more coming in that space over the next few months, through further evolutions of policy, further evolutions of how we manage policy, how we can give you feedback on how policy is behaving, and basically tying together all these different identities that lead to an individual decision.
Wow, really interesting. Is there also like a aspect of time where you restrict policies based on time? Like, a certain policy is valid till a certain time. It's kind of like sometimes
Yeah.
like do that with secrets. Like, can you do that with policies?
Yeah, absolutely. So we've had time-based policy conditions in the product for years now. So when you create a condition, one of the attributes that's available to you is the current time, and you can do all your standard time operations. Is it, how long has it been since X time, etc., and the current time, calculating skew and drift and those sort of things. So that's been in there kind of from day one. And it's kind of the additional contextual decisions you'll make. I think time's a really interesting one because if you look at what's going on with the service meshes and what you look or what you look when you look at what's going on with kind of AI agents, where you have some end user identity, they prompt some system, and that's going to trigger off a series of downstream actions. And one way to think about it is those downstream actions is a transaction in kind of the high level description of a transaction, not thinking specifically database. Um, and what you want to be able to do is actually restrict the permissions or attenuate the permissions that are given to the workloads, are given to the services on behalf of you, based on your permissions, based on your access, um, to be firstly attenuated to just the permissions that the agent flow needs based on what that agent flow does. But also you want to make sure that the identity given to those acting on behalf as the person prompting the system is only it only exists for the life cycle of that one particular prompt or one particular workflow. So you want to basically have a identity which is for that specific transaction. And Tokenetes is a project out there that's getting momentum around minting transaction tokens, which is a token that's a verifiable token that's limited only for one particular transaction through a system. So we're talking these things lasting seconds, potentially, rather than days or hours like a traditional access token might be. Um, and that, in terms of Cerbos' world, is just another identity that you can give Cerbos. So Cerbos can use your original JWT of a user that's authenticated, but we can start and use the attributes about it. But we can also verify how long, and going back to your example of time, how long that process has been running or how long that transaction has been running for, and verify that transaction using a transaction token within policy to determine, okay, this time has now lapsed. This transaction token is now valid. We're now going to start denying every action that your workflow is going to do. And this is the model we need to move to because now we're going to have workloads calling other workloads or agents calling other agents. And this thing, what may be one user inputting something quite trivial, could actually result in a numerous set of unplanned or unexpected or unpredictable downstream work happening inside of a system. So we need a way of putting a kind of a rope around them and ring fence what they can do and the impact they can have. And the only way you can do that is by having actual concrete identities for each of those steps, having a concrete signal for the whole transaction, and then having an enforcement layer and an authorization layer that can come in and be the decider, be the enforcer of what these systems can actually do and are allowed to do given context such as time and runtime and network environment, etc.
Really interesting. Thanks for that really detailed response with all of those steps that you explained in there. You really got into like the nuts and bolts of how the process actually flows. I wanted to zoom out a bit
Hmm.
and talk about like the top level in the architecture and just the different pieces involved. And I was wondering if you could even show us a sort of an architecture diagram and talk us
Absolutely.
like the different parts of the product that are at work and what each of them do.
Yeah, sure. Let me just bring up my screen. Uh, there we go. Yeah, so this is a diagram actually, if you sort of last time I joined you, we talked about as well. And
Yep.
going back to what I said earlier around how we haven't had to actually change our product at all to support these other use cases.
Mhm.
But the context in which you read these architecture diagrams and where you look at things is slightly different. So
Mhm.
at a high level, you have your client applications, be it a website, a mobile app, maybe just an API. Um,
Mhm.
and at this stage, you want to sort of make requests off to your backend. So request at this point is going to probably be authenticated. So you've already gone through an OAuth to authentication flow. Back on the client side, you have a signed JWT JOT that you can pass around. And so your client application will start sending requests off to your backend. And this comes into your environment, as you can kind of see here. And that request most likely is going to go through an API gateway. Now, at the API gateway layer, there's already some levels of authorization you can do. So at a gateway layer, you can start making, you can have a policy decision point like Cerbos starting to make decisions around, okay, well, is this token not valid or not? If it's not, you reject the request. Or if it is valid, you can do some high level checks. So you want to check maybe the scopes of the claims inside of the token to determine whether the request should even be allowed through the gateway or not. You can even start looking at things like the specific route. If you're using HTTP, you can look at the route, the headers, etc., to make decisions. So you can actually do authorization right here at the gateway using policy. Again, based on both. At this point, you only know who the user is because that's the identity coming in. So you can do those checks. At some point, it goes down to the API gateway. Maybe you're using a service mesh like Istio, Linkerd, etc. At the service mesh level, that's when you start making decisions around whether services can call or workloads can call each other. So this is where you can use the policy decision point to start determining, using, say, the spiffy identities of those services, whether those services are allowed to call each other based on their namespace or trust domain or those kind of other factors that you get with the spiffy framework or other workload frameworks. That I think spiffy is becoming the dominant one, given the cloud providers are supporting it natively now. So the service mesh will allow, okay, it's come from the gateway. Now it's in the service mesh. Is this workload identity allowed to call into the service mesh? So is the gateway allowed to call down into the microservice behind the scenes? That makes a decision. You then come into the kind of the application layer. So this is the actual microservice you are building and you are running as a development team or as a product team. So now in here, you now know, right, this request is valid through the gateway. It's valid through the service request. It's now been handed off to this microservice. This microservice has its own spiffy identity. It also has attached to it the user identity from the upstream request. You can go off to your IDP to go and fetch further metadata and context about the user. And now inside of that microservice, you want a user to be able to do an action. So, Twain is trying to host a podcast, let's say. So that action has a handler. Inside of that handler, you now can aggregate together. Here's the upstream user. So here's Twain. Here's the workload identity. Here's the microservices identity being this action is being performed on. So we can go and fetch that spiffy identifier or the workload identifier that service is running as. And now it can pass to Cerbos. All right, here's the user identity. Here's the workload identity that's handling this. And here's the context, time of day, etc. And here's the resource and action being done. So can Twain from the podcast publishing service in the production namespace environment do the publish action on this particular podcast, let's say. So you have all this context, and you now need, and then you would pass all that to Cerbos, and then Cerbos, using its policy-based approach, has policy for the podcast publish action, let's say. And inside of that policy, you would have checks for, okay, is the user authenticated? Yes. Is the token valid? Yes. Is the user in the podcast management group? Yes. Is the publish action being performed inside of the production, say, GCP GKE cluster? Yes. In the right namespace? Yes. And the time factors, is it in office hours, let's say, have been checked. And you can have all that defined as a version auditable testable policy. And then the PDP, the policy decision point, has that policy loaded into it. So those policies are coming from a policy store, be it your own Git repo or some managed store, being managed through Cerbos Hub, which is the CI pipeline that manages, compiles, tests, and distributes policy out, and pushing out to your policy decision points that are running local in your environment. So now your application or your service or your service mesh or the API gateway is doing a local call to a local PDP running alongside your application. It evaluates the policy, comes up with a decision, creates an audit log. At this time, this user from this workload identity trying to do this action, this resource, and it was allowed or denied by this particular policy. And then in your application, you simply go, did Cerbos say allow? Yes. If not, deny. But what this now means is whenever your credentials change, the workload identity changes, the policies change, the request changes, you're doing real-time contextual authorization checks at the point of request being handled. So whenever a context variable changes, maybe you have a risk engine that's scoring interactions. If that signals that, hey, this is now a high-risk user, your authorization policy may say, okay, now I'm going to reject the request and tell the application to redirect the user off to the IDP to do a step-up authentication, let's say. So you get this very, very granular, contextual, multi-layered level of authorization, which allows you to go to that true zero trust architecture because you're not trusting the network, you're not trusting the service mesh, you're not trusting the cluster, you're not trusting the IDP. You're doing individual evaluations in sub-millisecond timeframes at every single layer, and that truly gives you that zero trust architecture that is now finally possible, given the tech stacks that are now out there.
Mm-hmm. Yeah, wow, that's powerful stuff. Yeah, and you explained it really well. As we were talking about these things, one of the questions that came to my mind is just that I'm thinking that a lot of organizations probably use multiple tools to do
Mhm.
different parts of this entire process, and
Yes.
be spread too thin. Uh, how do you how what would you tell someone like that who's thinking about, how do I decide my tool stack? Should I let go of some tools? Should I, integrate them better? How do I
Yeah.
think about all these different solutions for this entire process?
Standards would be my shout out. You should be building and architecting based on standards. So authentication, OAuth has become the predominant standard for that. JWTs are a standard. Authorization space, there's a emerging standard called from the OpenID Foundation, of which we're part of, called AuthZen, which is standardizing how applications talk to policy decision points like Cerbos. Um,
Mhm.
and there's Spiffy is a standard. Um, you could argue Kubernetes UC's point is almost a standard. Um, and simple HTTP and gRPC, they are standards. So that's where I'd begin. Look across your application landscape. Go and look at the components you have in place. And there isn't a single platform that does all this now, and I don't think it makes
Mhm.
sense for there to be. It's always going to be the best of breed solutions that take off each of these components. So on your architecture diagram, you need an IDP, you need a directory, you need a gateway, you need a service mesh, you need a authorization system, you need a XYZ, and really going out there and looking at what are the systems that I can put into each of those boxes. You probably
Mhm.
have quite a lot of them. You most likely have an IDP. You probably have an API gateway. You may have a service mesh, and start populating each of those boxes and figure out what to build, what to buy versus what's an open source, because that is now very much a solution these days. With Cerbos, you can use our open source project. You never need to talk to us. We also have a commercial product that does it as well, with some much needed workflow and management capabilities on top. And really go through each of those components of your part of your stack, and go and look at the reference architectures for zero trust architectures, let's say, and go and start figuring out where you have the gaps and do a bit of a gap analysis, and then go and find the solutions and services that fit in there, but make sure that you are avoiding any sort of vendor lock-in by making sure you're using and only selecting vendors that are using open standards. Because the moment you need to say swap out an IDP, if it's not using OAuth, you're going to have a hard time. Same for your authorization layer as well.
Mhm. Wow, really interesting. And it's good to see that there's so many standards that are, coming together, and kind of, that they work together well. And it's a good time to be doing this kind of stuff, being in cloud native. It's amazing to see all of it come together, and you really, brought out these different efforts from all these different projects,
Yeah.
and how they work together well.
I,
Really
I,
amazing.
I think the most one of I want to say heartwarming things, but one of the most positive signals I kind of got, if you look at, I'm afraid we have to talk about AI now. If you go and look at what's going on with the Model Context Protocol, which is the standard for how to provide context for an LLM, created by Anthropic, but it's an open standard. If you look at their specification for how to handle authentication between MCP servers and MCP clients, rather than reinventing the wheel, it just uses OAuth to credential flow or OAuth to authentication, which is really, really good and a really positive signal that the component parts you're building up can be interoperable, they can be reused. So if you want to now say go and you have a MCP server for your internal applications, you rather than have to go and potentially build a whole new authentication layer, you just go and plug in your existing IDP, and now that is then used for the authentication flow between a host and a client inside of your systems.
All right. Wow. Last question I have for you, Alex, is just around how you're starting to see the uniqueness of Cerbos with all of this happening. With so many different tools taking different
Mm.
approaches, different categories of tools. You got, like you mentioned, the IDPs and service meshes, API gateways, there's vaulting tools. There's so many tools that are coming up solving these same challenges. But what is something that you're realizing is very unique that Cerbos brings to the table, and that you're starting to see even Cerbos itself in a new light because of all of these developments?
Yeah, absolutely. And I spoke to kind of the flexibility from some of the earlier design decisions we had, where we're kind of agnostic to identity. sources means we're not coupled to particular IDPs. You can use any identity source that comes to Cerbos. So you start passing out workload identities, Cerbos just works. You don't need to do it. But I'd say the other piece, which when we did it, was for good reasons. We went through a bit of a rough patch with adoption because it is a bit of a mind shift, and then but now it's proving to pay off big time, which is around statelessness. So when it comes to authorization, you really have two models. You either have a model where you have a big old sort of authorization database that stores the permissions and relationships between resources, and so the application just needs to pass user ID, resource ID, and action, and then using that big state store, it will go and evaluate the decision and come back with an answer. Or stateless, which is the Cerbos model, where the authorization layer doesn't store anything except your policies. And all the context about the resource, the user, the action, the context has to be passed at request time from the application layer, the model layer, the database layer, the enforcement layer, wherever you're doing it, to Cerbos. And then Cerbos is a pure policy engine that can evaluate all the decisions in memory. And the reason why we built it that way from the start is sort of my background and my co-founder's background is building high throughput, low latency data processing systems. So I've made every mistake possible around eventual consistency and edge deployments and high scale deployments that you can, and have a lot of battle scars from dealing with those. And one of the things that we knew very early on is if we have to maintain state and then also scale that state out and distribute that state out, you're going to have a bad time. So the decision we made from the start of Cerbos is Cerbos will not store any state. And the kind of the rough patch we went through, you could say in the middle is there's a whole class of companies that find that quite tricky to implement because you now need to go and aggregate state yourself and pass all that context to the authorization layer at request time. There's some architectures that are fine for that and happily go and plug in. There's some other architectures that may be a bit more challenging and they have to do a bit more re-engineering to get the state in the right place and essentially taking Cerbos and wrapping it in their own state system. But what this now means is we're now in a world where you're going to have these ephemeral jobs, ephemeral workloads, ephemeral identities. Having a stateless architecture removes a whole load of complexity because, if you imagine if you're spinning up an NHI or workload identity for the scope of just one transaction, now if you had a stateful model, you'd have to go and create that ephemeral identity inside of your IDP, wherever you're storing it. Also synchronize that to the authorization layer. Have that authorization layer distribute that out to all its policy decision points. Then make a decision, and then delete and go through the process of removing that identity when it's cleared up. For the time it takes that state to get distributed, your workload could most likely already be done if it's a very quick workload job, and you're basically going to delay the whole system by having to manage this state. So Cerbos is much better placed for these very ephemeral, short-lived type authorization checks you need to do to truly build out these build out these pipelines and workflows, be it AI based or agent based or not, and transaction based or not, and do that fine grained authorization in that context without holding things up and getting those snappy decisions across the entire stack.
All right. Wow, very interesting conversation. With that, we come to the end of this episode. And before you go, though, Alex, just one more question for you to get to know you a bit more. As a co-founder, chief product officer, you wear many hats. You in a startup, you do different roles.
Right.
And I want to ask which most resonates with you. Would you say you're more the developer, more the teacher, more the collaborator, people person, more the marketer, more the product guy, or something else, the systems builder? What kind of guy are you?
I've said this numerous times now, but I don't think I could ever do another job. I don't think I could ever go and work in another company because the hat I like wearing the most is the fact that I get to wear all the hats at different times. If I was doing the same thing day in day out, I would not enjoy life. I think that's the reason why I'm so drawn to doing startups is you are get to do a bit of everything and you get to do everything to a point and then hopefully your business is successful and you go and hire an expert to do that part of the job and I can then just dip in and out of when needed, and kind of let that team grow and flourish. And our marketing team is doing a great job right in that sense and I don't really have to do so much marketing anymore,
Mhm.
and I can wear a slightly different hat. So I think the ability to wear different hats is the hat I like the most. That's a bit of a cop out answer, a meta answer, if you will.
Okay, okay. But is there any one that even energizes you more than others?
If I'm having a really bad day, I just want to sit down and write some code. That's my go-to. That's my happy place. Call it
All
vibe
right,
coding
okay.
if you want. But Make it clear, my code should never go near production, but I like building POCs, I like building little tests.
Neat, neat. Cool to get to know. All right. With that, we come to the end of this conversation. Thanks for joining us today, our listeners and viewers. And if you like what you just heard, go and check out what Cerbos is up to. Their website is cerbos.dev. Is that right,
Yep,
Alex?
that's it.
All right, Cerbos.dev, and they've got a release that's coming up. I think a major release that's coming up in about a month or so. So sign up to their newsletter and just keep track of their updates because they are launching some big stuff, and we'll get Alex to talk to us about it maybe later this year or early next year sometime.
Lovely.
Uh, that's it for this episode, and we hope you'll join us for the next one. Thanks so much. See you then. Bye bye.